Right, we're asked to evaluate this expression. We're being asked to multiply two complex numbers here. Just a real quick review. A complex number is a number of any form of a plus or minus bi. This I part is the most important part of that. I is the special number that when you square it, you get -1. That concept is the most important thing to understand about the imaginary numbers, is that I squared is -1. I is the only number that when you square it, you get -1 out. Okay, so here's what we're going to do. We multiply in the same way that we multiply binomials. This is like a FOILing process. We're going to multiply each term of the first polynomial by each term of the second here, or in this case, complex numbers. So 2 times 3 gives us a 6, and then 2 times 3i gives us 6i. Throughout this process, by the way, we're going to treat these terms that have i's just as if they were any variable, like x's or y's or not. So 1i times 3 is 3i, and then the 1i times 3i is plus 3i squared. All right, so that's it. That's exactly like, again, as if we had x's and y's instead of i's here. Just to clean this up real fast, I am going to combine the like terms, the 6i and 3i. That will give me a total of 9i. And then I have this 3i squared, but super important is I'm going to apply this property now, that I squared is the same thing as -1. So in this last term, this is really a 3 times a -1. And what that has the effect of doing is it just changes the sign of that last term. And I'm going to combine the like terms of 6 and the -3 to get a 3, and then times 9i. And just a continuation real fast on this, again going back to the definition of complex numbers, which is a plus bi. We call a the real part and b the imaginary part. So if you needed to list these, let's say like in a computer program or not, the a value here, or the real part, would be 3, and the b would be 9. So there you go.